The question of whether we are alone in the universe has long fascinated us as a species. More recently, though, a secondary question has captured our imagination. If there are aliens, then why haven't we found them yet? This question comes from one of our sixth formers and is what we're going to take a closer look at in today's video. Yes. What do you mean I need to explain it more? From a statistical point of view, if you consider the number of stars in our galaxy alone, let alone the whole universe, there must be multiple star systems with planets at the right distance to them to make these planets habitable. Now, not all those planets are going to have life evolve on them, but the thought that we're the only star system in the universe to have life, and that it only exists on our planet, seems a little too unlikely for me. But don't take my word for it. This is something that has been considered by many more established scientists within the field than myself. One such scientist that we could look at would be Drake. No, not that one. Sorry, that's not like us. Can we make a minor change there? There we go. Excellent.
In 1961, Frank Drake came up with this equation in an attempt to determine the number of civilizations that we could possibly communicate with in the Milky Way galaxy. He determined that it would depend on a number of factors, including the rate at which stars form in the Milky Way, the fraction of those stars with planets orbiting them, the mean number of planets from those stars that could potentially support life, the fraction of those planets that actually develop life, the fraction of those with intelligent life, the fraction of those where they can broadcast signals of their civilizations into space, and the length of time that these civilizations are capable of releasing signals that are detectable by us.
Depending on what information you base your particular values on, you could end up with a very conservative or quite optimistic view of just how many civilizations there are that we could come into contact with. Also, some variables in the equation we do have to massively speculate on, like what proportion of its existence that a society would be able to broadcast for, making this more of a fun concept than something to give us a definite value of how many alien civilizations we feel are in our own region of the universe. Quite a lot, and not enough, to be honest. Within the solar system, we have looked for signs of life on Mars in particular. This stems in part from a mistranslation from observations by an Italian astronomer in the late 1800s, Giovanni Virginio Schiaparelli, who observed a series of straight lines or canali, literally channels, on the surface of Mars.
This was misunderstood as canals by some, including Percival Lowell, seen here on a good day, who thought that these lines represented where crops were being grown in mass numbers on Mars and the irrigation canals that provided them with water.
Even though the existence of canals on Mars has been thoroughly disproven, the search for life there and elsewhere in the solar system has continued, with soil samples analysed by the rovers and landers that we've sent to Mars over the years to look for the same sort of chemical compounds that we associate with life on Earth. As yet, we've not found anything on Mars to indicate the existence of life forms, either past or present, but it is not the only target within our solar system that we're interested in. It is believed that some moons of gas giants, including my favourite Europa, which orbits Jupiter, might have subsurface oceans, and scientists are very keen to explore these in a search for life. If we look further afield, though, at planets in other star systems, we have to be a bit creative in how we search. A simple telescope, no matter how good the zoom is, will not be able to see the fine details on a planet in another star system, let alone whether there are any signs of life. What we can do is analyse the chemical composition of these planets by looking at the light that they reflect towards us. By comparing their spectrum with the spectra that we can produce from sources in labs and view through a diffraction grating, then we can determine if the atmospheres on these planets have a similar chemical composition to our own. In addition to this, we can look for signals being sent out by other species. There are numerous groups looking at this, some professional with government backing, and some from amateur astronomers. At time of recording, we've not had any convincing evidence of signals that we believe are from other life forms in the Milky Way, although there have been a few false starts along the way. But that's definitely not going to stop astronomers from continuing the search. Whilst we are looking for signals of life elsewhere in the universe, we are also sending radio signals from Earth. Not all with the intention of getting in contact with aliens, but simply because the signals we use to communicate with are in the radio and microwave ranges of light. Now, most of these can pass through the Earth's atmosphere, meaning that we've been broadcasting our whereabouts, intentionally or otherwise, for nearly the last 100 years. If aliens pick up any of those signals, they could work out where they came from and decide if they want to actually interact with us. We have also included information about humanity on various satellites that we have launched into space.
Frank Drake worked with Carl Sagan and others to develop the Pioneer plaque, which featured imagery communicating about humans, our position in the solar system, and other information. These were mounted on the Pioneer 10 and 11 spacecraft in case either was intercepted by extraterrestrial beings. Building on this, the Voyager missions carried the Voyager Golden Records, featuring sound and data about the human race that would give a flavour of our culture in the 1970s when they were launched, as both an introduction to our species and a time capsule of sorts.
Quite simply, we haven't been looking very long. If you compare the duration of time that we've had access to radio telescopes, less than 100 years, to the time humans have been around, we've only been searching for a fraction of the time that we've actually lived on planet Earth. We've also been broadcasting for a limited amount of time, meaning that the signals that we've sent out from Earth will have travelled less than 100 light years. When you consider that the Milky Way is around 100,000 light years across, we've only sent very weak signals to a tiny section of our galaxy. So if we've not been found yet, it's no wonder. So, do I think that we'll find aliens in my lifetime? Perhaps. But also, perhaps not. We'll have to watch this space on that one.
On that topic, our next video is going to be a slightly different one, so stay tuned for that, hopefully uploading next Friday. Thanks again to everyone who has watched the videos so far from us, and especially those who have given us a like or subscribed to the channel so far. Take care, and we'll see you soon.
This stems from part of a mistranslation of an observation from an Italian astronomer in the late 1800s, Giovanni Virginio Schiaparelli. The late 1800s, Giovanni Virginio Schiaparelli, who observed a series of straight lines, or canali. I got all the way through and fudged up canals. 1800s, Giovanni Virginio Schiaparelli, who observed a series of straight lines, or canali, literally channels, on the surface of Mars. Yes, I did it!